Hey, what's going on, guys? Let's do this problem right here. This question is asking find the radius and intervals of convergence of the following series. Let's see how we can do this. So first of all, what we have to do, we have to take the ratio test and find the value that is less than 1. So here we are going to have, if you take the ratio test, this is going to be limit n approaches infinity, absolute value of an plus 1 over an. So this is the ratio test generic pattern. Now let's go ahead and do that for this one. So for this one, this is going to be limit n approaches infinity, and wherever we have n, we just have to add 1. And here we are going to have x power n plus 1 times 2 power n plus 1 over n plus 1 factorial, right? And then we have to divide by an, that is original function. Dividing by this one is same as multiplying by the reciprocal of it, right? Because dividing is going to flip that anyway. So we can directly multiply by the reciprocal. That's going to be n factorial over x power n times 2 power n. And if you notice, this one cancels, and this one cancels, and this one cancels. So we are going to left with, so this is going to be 2 n plus 1, right? So we are going to have 2 times, so let's put the limit 2. So we are going to have limit n approaches infinity, 2 times 2 times n, actually n factorial cancels all together. So this is going to be, so there's no n right here, and in the denominator we are going to have n plus 1. How did I get this? If you notice, x power n plus 1 is same as x power n times x times 1, and if you divide by x power n cancels, and this is actually x, right? So here we have to have x right here. And then this 2 power n also same thing, 2 power n times 2 power 1 is same as 2 power n plus 1. Divided by 2 power n, cancels, 2 power 1 remaining. That's how we got this 2. So here we have x, this is 2, and then in the denominator n factorial over n plus 1 factorial. And if you know the expansion of factorial goes like n minus 1, n minus 2, and this goes until 3 to 1, and it to end with 1. And for this one is going to be n plus 1, n, we just have to subtract 1 each time. So this is n plus 1, n minus 1, and if you notice, all the value less than n plus 1 is going to be same as this one. So that's how we cancel this one. So that's how we cancel this one and got this value, n plus 1, right? Now this is going to be our value. Now we can move this everything except n value to the front. So this is going to, we can take this 2x to the front. So this is going to be 2x limit n approaches infinity 1 over n plus 1, right? And if you take the limit of this one, this is going to be 0, because we know that 1 over infinity, that's going to be 0. So the limit is going to be 2x times 0. This is, so we take absolute value, absolute, since all of these are in absolute value, right? So we can say, right, 2x times 0 is less than 1, right? And no matter what value you put for x value, if you multiply 0, that's going to be always less than 1, because always going to be 0. So you can say any value. So it means the intervals of convergence is going to be negative infinity to infinity. So this is intervals of convergence. Convergence, right? because no matter what value you pick between this, you always get 0 that's less than 1. So that's what we want in intervals of convergence. And then radius of convergence is going to be absolute value of this one. So absolute value always going to be positive, so radius is going to be positive infinity, and that's going to be the final answer. I hope you guys find this video helpful. See you next time.